Go ahead, Maddie. All right, so this is going to be geometry.
I want to do it.
Okay, this is going to be geometry. We're actually doing application of problems. Okay, application problems. So we're doing a lot of the math that we've done already, but now we're actually going to use it in real situations. Okay, so the real situation, I gave you guys a ruler for this piece right here, and we're going to go over this. So, starting here, use the figure at the right for these problems here. So they got renumbered, so forget that part. Yeah. Anyway, all right. Right here, I'm going to look at this. So what is the relationship between MB and JK? But before I do that, I need to start talking about the different parts of these two triangles. What's on here that is not labeled yet? Look at the diagram. What's on there that's not labeled?
The other right triangle.
Very good. The other right triangle. So the other side. Good job. Now, is there anything else that's on here that is not labeled?
The 2 tick marks in the middle.
Excellent. Very good. So 2 tick marks on the reflexive. So right here. So now, if I look at the two triangles, what can you tell me about the two triangles here? They are going to be congruent, right? So I could say that triangle JBM is going to be congruent to triangle KBM. By what reason? SAS. Yes. Okay, it is side angle side, side angle side. So they are going to be. But we're not doing a proof on this. You just need to understand certain things that go along with this. Okay, so now from doing this, I know that these two triangles here are congruent. So, since these two triangles are congruent, what do I know about all their parts of the triangle? They are corresponding, but what do we know about corresponding parts?
180. 180.
No, they're not 180. No. What about, okay, so let's back up a second. The two triangles are congruent, right? So the corresponding parts are congruent, right? Is there some theorem or formula or postulate I could say that they're all congruent? Anyone recall what that is?
CPCTC.
There we go. Now, remember the mnemonic for that. Chocolate, peanut butter,
Cinnamon Toast Crunch.
Cinnamon Toast Crunch. There we go.
Or penguin crab Toyota car.
Good try. Okay, so chocolate, peanut butter, cinnamon toast crunch. So corresponding parts of congruent triangles are congruent. So that means that all pieces of this triangle are congruent to the corresponding pieces of this triangle. Right? Okay, so now let's look at this. What is the relationship between MB, right here, and JK, this one right here?
Definition of midpoint.
It is midpoint, okay, but it's a line though. It's a bisector, isn't it?
Yeah.
But what type of bisector is it?
A perpendicular bisector.
Bam, there it is. Let me throw candy at you.
No.
There we go.
Dang.
So, that this is a perpendicular bisector, MB is a perpendicular bisector of JK.
Oh, wow.
So, perpendicular bisector, so it's cutting this into two equal parts, and it makes 90-degree angles when I do it. So I have perpendicular bisector there.
Perfect.
Now, I know, because of that, what do I know about these two sides over here? They are congruent. Very good. So I'm going to put some markings there. So 1, 2, 3. 1, 2, 3. So these two are congruent to each other. So how would I go about solving for x? I heard it. Set them Very good. Set them equal. That's what I'm looking for. So I'm going to set them equal to each other. So I'm going to write 9x minus 18 equals 3x. Very good. Minus 9x. You want to subtract 9x from both sides. Very good. Thank you. Negative 18 equals minus 6x. Very good. Now, what am I going to do next from right here?
Divided by -6.
Divided by negative 6. Very good. So x is 3. Very good. Yes, x is 3. So I solve for this one right here. Let me put that right there. Now, find Jm. Jm is this piece right here. Yes, you're kind of got a little bit ahead of me there. Okay, so it's that piece right there. And go ahead, TJ. What does it say?
Maybe 9. That should be 9.
Okay, so we're gonna plug it in now, right?
9 parentheses 3 minus 18.
Very good. So we're plugging 3 into the x value I have right here. And so when I do that right there, it's going to give me what?
9.
9. Very good. So I do the math. It's 27 minus 18 is 9. Yep. Okay. So that's that. Now let's go ahead and take a look at this one right here. So I don't know if you guys can see it. So the Union Square is right here. And 14th Street Station is right here. Now, with your ruler, you guys are going to draw a line in between those two.
Which one? Which two?
Can't see what?
Draw a line like connecting them.
Yep. A straight line connecting them. There we go. Now, I'm going to do some process of elimination here to try and help you guys out. It says, which school is equidistant? Now, the word equidistant means what?
In the middle. Well, like same each way.
Same. Say distance.
Be Coleman. Coleman.
Distance.
Right.
Same distance. That's what I'm looking for. I want a place that is going to be same distance from the subway station at Union Square and 14th Street.
Coleman.
So we're going to go through and we're going to do a process of elimination here. So that means it has to be exactly the same from Union Square to 14th Street. So is it going to be the museum?
No.
Nope. Cross that one out. Is it going to be the Village Kids Nursery School?
No.
No. Is it going to be Legacy School?
No.
Now, is it going to be Xavier School? Okay. Process of elimination. Okay, maybe it's like a medical school or something, but you know, we'll see. So somewhere in between here. So this is what you guys are going to do. I want you to measure this, and we're going to find the middle. Okay, we're going to find equidistant. So I'm going to use the centimeters portion. So on my thing, I'm going to look, and I have about, so I have 5 centimeters.
It's so dark in here.
I have 5 centimeters. So what is the middle of 5?
2.5.
2.5, very good. So 2.5, I'm going to put a mark right there. Put a mark at 2.5, so that's 6th Avenue. Now, I'm going to extend my line at 6th Avenue.
I got an accident.
Hey, shh. How'd you get 5.5?
5.5, yeah, me too.
Yours is wrong.
Yours is beautiful.
Mine is wrong? I'm going from 0 to,
We have different
That's it, 4.5.
oh, okay, so even if it is 5.5, where would the middle be?
Exposed.
B3.
It'd be on 6th Avenue.
It'd be 2.75, which is still right here anyway.
Right.
Yeah.
It's still 6th Avenue, right? Okay, so now I drew a line right there. So what did I do to my line?
You cut it in half equally.
Cut it in half. So what's the word for that? Bisect. Very good. So I'm bisecting it. So now I know that this piece here is congruent to this piece here, right? So if I take a look, anything on this line, so this is going to be called the perpendicular bisector. Now, with the perpendicular bisector, that means that I have what type of angle right here?
90-degree angle.
90-degree angle. So I have right angles here. And also same on that side, right?
Sure.
So, if I want to measure it, anything that is going to lie on this line will be equidistant from there to there. So, if I say, for this one right here, it's going to end up becoming which one, TJ?
Coleman School.
It's going to be Coleman School. Okay? Now, how do we know? How do we know?
Because it's on the street, it's equidistant.
Because it is equidistant, it's on the perpendicular bisector, right? It is on the perpendicular bisector. It's on the perpendicular bisector. Now, let's take a look at number 5. It says, is St. Vincent Hospital equidistant from the Village Kids Nursery and Legacy School? Okay, here's St. Vincent's Hospital right here. Okay, so first, I want the Kids Nursery and the Legacy School. That's going to be, Kids Nursery is right here. Legacy School is right here. So let's figure out how far those are apart. So that's going to be about what?
1.1.
Are you using a centimeters?
Yes, sir.
So I got 2, almost 3. Right? Okay, so if it's almost there divided by 2, so it would be a little bit less than 1/2.
You gonna use 2?
Huh?
You gonna use 2, like just be safe with 2?
I'm sorry, I didn't understand the question.
Well, what are you using? What number you gonna use? 3?
No, I'm going to use this right here. So I'm going to basically say it's 3. It's closer to 3.
That's fine.
Half of 3 is 1.5, right?
Oh, sorry.
1.5.
Yeah.
Okay, so 1.5, so it's a little bit less than 1.5. So I'm going to put a line right there. And I'm going to use that as my perpendicular bisector.
It's like the same.
Basically the same line, isn't it?
It's not on there, so it's not right.
So, is St. Vincent's Hospital equidistant from the Village Kids Nursery or Legacy School?
No. Nope.
No, it is not. And it says, how do you know?
It started on perpendicular bisector.
Not on the perpendicular bisector.
You want sharpener?
Oh, you need to stop throwing things in the dark.
You hit me in the chest.
All right, so let's take a look at this next one here.
Oh, you serious? Something like that.
Okay, so again, I had to renumber this, so ignore that part. So, according to the diagram below, how far is L from HK? So, let's first identify the information I have. So, I have that this piece here,
They both got to be 27, right?
yes they are. I have this angle is congruent to this angle. Now, what is here, but it is not labeled?
Let's see.
Very good. Reflexive again. So I have they both share a side, so it's going to be reflexive again. So I'm going to put 2 tick marks there. So are these two triangles congruent to each other? Yes. How are they congruent to each other?
No, side angle, side.
Side angle side, side angle side, right?
Angle, side angle.
No, I don't know the angles yet.
Possible.
Okay, so they are congruent by side angle side. So now we could actually know that after that they are congruent, I could say what about their parts? Okay, it is. Very good. Say it.
Yeah. What's the wrong side?
Alright, so how do you remember it? Chocolate, peanut butter, cinnamon toast crunch.
Or
Shh, no, master, just stop. Alright, so we have this much information. So since I know that they're congruent, that all the parts are congruent also. All their parts are congruent. So now let's go through and actually look at some of these things. According to the diagram, how far is L from HK?
Could you do like 6y equals
Here's L
7?
Oh.
and here's HK. How far is L from HK? How far is L right here? I'm looking for this one right here.
27.
It's going to be 27 because this is HK, isn't it?
Yeah.
So it's going to be 27. And how far is L from HF?
27.
27 because they are congruent, right? Very good. Now, how is HL related to KHF? So if you need to draw on this, you can. So it's going to be close.
It's a bisector.
That's what I'm looking for. So here's the angle right here. It's asking for HL. HL is bisecting this because it's going to be cutting it into 2 equal parts. So HL is the angle bisector.
What's the difference between midpoint and bisector?
Midpoint is a point. It's a single dot. Where a bisector is something that cuts through it. Okay, so a line will bisect something. Okay, where a dot would be right in the middle. So it's not cutting it, it's just pointing it out where it's at. Does that make sense?
Yeah.
Okay. So it says HL
Wait. Okay, yeah.
is angle bisector. There we go. HL is the angle bisector of this. Now, if I know that, I know that all the pieces are congruent to each other. How would I solve for Y?
6y equal. Would you like split equal to each other?
Why are they equal to each other?
Because they're just, like supposed to be equal. They're supposed to be.
Are they congruent because they're corresponding parts, right?
Yes.
Very good. So I got 6y is equal to,
4y plus 18.
very good. Like that, right? Yes.
Is it an exponent
Yes.
of 6y?
No, that's just the degree symbol.
Oh.
That's the degree symbol. It's actually talking about the angle in the degrees. All right, so what would I do to both sides of my equation here?
Subtract 4.
Very good.
4y.
So I'm left with
2y equals 18.
18
Divided by 2
divided by 2.
is 9.
Y is 9. Y equals 9. All right, so now find the measure of angle KHL. So I have KHL. So what would I do now if I'm looking for this?
What if you divide by?
No, I'm not going to divide it.
Oh, you just enter 9 to y, right?
Yes, very good. That's what I'm going to do. Because look for KHL. So it's this angle right in here. It's this piece right here.
There's 6, like, yeah, put those.
So it's going to be 6 times 9, right?
Would you add 27?
Why would I add 27?
Because it's on L.
No, because I only want this angle right here. Because see right here where it says the measure of the angle? I only want the angle.
Alright, this 54.
So 6 times 9 is 54. Now the next says measure of angle FHL. FHL is this one in here.
You just gotta be right, so 54.
It is, but I could do the math before it too, right? So it should be 4 times 9 plus 18. So my math is going to give me what?
54. What if it doesn't give you that? Does that mean you did something wrong, or like does that possibly happen?
Yes. If it doesn't give you that, then somewhere you did something wrong. So check your math on both of them. Make sense? All right. Questions, concerns, complaints?
No, but I know the acronym again.
Okay. Don't forget, like and subscribe.
I already comment on your video.
Yeah, comment. Leave a comment.